All right, we also have a power to a power rule. If you take an exponent to some power, the rule for this is you're going to multiply their powers. Okay, and so if you were to look at, let's say, x cubed to the 5th, that's equivalent to x to the 3 times 5 or 15. All right, the final rule is when you take the absolute value of a perfect square. Okay, do you need the absolute value symbol around this? Or is it redundant? Okay, when you square something, can you ever get a negative? No, the square itself guarantees a non-negative value. Well, what does the absolute value guarantee? Non-negative value. So in this particular case, no matter how you look at it, it doesn't matter. You're just going to take a square. So a perfect square inside of an absolute value is unnecessary. It just gives repeated information about the same thing. Okay, so let's see how all these rules kind of come into effect. And if I gave you something like this, and I want to see if you can simplify this expression using only positive powers. And so rewrite this expression using just positive powers. Your strategy might vary, and sometimes it's easiest to apply the power first, sometimes it's easiest to apply the negative, the rule of the negative power. What I would do is I'd apply this power to every base. And now, some students refer to this as distributing the power. That's not what it's called. And distributing has to do with taking a product or two factors, one factor of binomial or multi-term expression, and distributing or multiplying through to each term. This is just a single term, so we're not distributing through terms here, but you can apply this power to every base. So if I apply it to the base of negative or a 4, I apply it to the base of x. Well, what do you do when you take a power to a power? Multiply, so negative 5 times negative 4 is 20. Y to the, again, power to a power, 24. And z to the negative 8. Okay, so in this particular case, it's probably easier to get rid of or work your grouping symbols first. The order of operations, first thing is get rid of your grouping symbol. And now you can go back and work with your negative powers. Any base that has a negative power gets moved. So the 4 has a negative power, so we're going to move that in the denominator. The x has a positive power, so that will stay where it is. The y has a power that's positive, so that'll stay where it is. And then the z has a negative, so we'll move that z to the denominator and change the sign of its power. So this is where you could leave it. If you wanted to simplify the 4 to the 4th, you could. The simplified form is 256. You don't have to know that. You could leave it in this form, but these would be the two acceptable forms of this problem. All right, the last example I wanted to look at, and then I'll give you the rest of the time to work, is what if I gave you the product of these two numbers? Can you simplify this product? The x in that case represents multiplication. So 10t to the negative 3 times 5t to the negative 9. And again, write your answer in terms of positive exponents only. All right, does the power of negative 3 apply to the t or to the 10 and the t? Just the t. So if you're looking at that, the 10 is going to stay in the numerator. The t is going to go to the denominator. Although, again, before you even write this, and so you could think of it as this form. Okay, what about with the 5, t to the negative 9? Is this power of negative 9 applying to the t or the t and the 5? again, just the t. So really you're looking at this as your rational form or fraction form. And now when you multiply, or you don't even need to think of it in these terms, if you just take the like parts, and so all numbers, the real numbers are alike, so what is 10 times 5?
50.
50. Okay, the power is positive, so it stays in the numerator. And then what's the rule for multiplying two exponents with the same base? What do you do with their powers? Add. So negative 3 plus a negative 9 gives you negative 12. So really you're looking at 50t to the minus 12. And then what does this negative power do? Takes our base, moves it to the denominator, changes the sign to positive. And so you would be looking at 50 over t to the 12th as your simplified form.